And let's get pouring the salt in. Can you see that on the video? So this is a salt bridge we're making. If you get an air bubble in, you're screwed. So you have to do it while keeping a finger. Yeah, it's got many air bubbles. So I'm going to have to put a thumb, pour. Now why has it got, push that in there. In a normal COVID times we would have plenty of assistance. Okay, so there's our salt bridge, but it's still got some air in it. So let's try and get them the same height. Science is never easy, folks. Okay. Yoo-hoo! So, there is our cell, almost complete. Right. Salt bridge has got a little bit bubble, but it doesn't take up the whole space. Now I need a voltmeter to complete the circuit. So put it on 20. Attach this to the 1. Attach this to the other, and there you see a voltage of 1,05, and that is closer to probably what we would work it out on our table. All happy? Was that a little more sophisticated than using a lemon? Yes. Just a little bit more. But folks, this is how they work out the whole table. Did you see I put 1 mole per decimeter cubed at STP or whatever, at standard temperature, pressure? Did you see I put exactly 1 mole in? Good. You see I put exactly 1 mole in there per decimeter cubed? I was very exact. I weighed it out, put it all in, took the measurements, boom. Okay. Now, what's the next thing we're going to do? We're going to go to our table on page 350, 250. What's on top?
What's the name?
Liam. Who's on the bottom? Megan.
Megan Fox.
Now we're going to look for our 2 dating couple. We've got copper and zinc. Yeah, copper and zinc. Anyone remember, was that looks like it might be the copper one? No, that's the big one, that's the small one. Okay. Now guys, I want you to take a pencil and find for me zinc and copper.
Found it. Found zinc. Found copper. Who can copper be? Who can copper be? Always after man. Papa's on man. But he's after the so
Okay, what voltage did you get for zinc? What voltage for zinc? 0 point? What voltage did you get on the right for zinc? So here I find a reaction that says zinc 2 plus 2 electrons Did you find that one?
Yes.
Okay, so there you see the 1.07. Okay, let me move my camera. Okay, where's the copper? Now, how many of you found more than one copper? Hands up. How many coppers did you guys find? 2. There's actually 3 coppers. Put a mark next to each.
Open your eyes. Okay.
Okay, so here's the coppers. The closest one, first zinc is on the top. Then I see this one. Okay, now how do we choose which copper? Well, this is copper sulfate. Do you know what the sign on sulfate is? What's the sign on sulfate? What ion does it form? Guys, Alicia? Negative how many?
2.
Guys, you've got to learn your ions. Really, take a day, learn your ions. Because this is -2, what must that be? Must be +2. So now I know I'm looking for a reaction that involves Cu plus 2. Not that, no, that one is ruled out.
And the second one.
But that's got Cu2 plus. It's got Cu2 plus 2 electrons goes to form copper metal. This one's got copper 2 plus 1 electron goes to form copper ions. Now, of those two, which reaction am I going to choose?
The second one?
The middle.
Both middle?
I mean,
So, Jared, what have I got also in this beaker? I've got copper 2 plus, but there's some other form of copper I've got in this beaker. It is Cu? Cu?
It's also
Forget the SO4. What other form of copper have I got in this beaker? Copper? Copper, not iron. Metal. Which of these is copper metal?
You were talking about the equation.
Where's copper metal here?
I'm talking about the equation.
Which of these is copper metal? It says, no, it doesn't say solid. Is that a metal?
Yes.
Is that a metal?
Yes.
No, that's aqueous. That's got an iron. So look, you see, Joe, we've got copper 2 plus there, and we've got copper solid there. So do you see how easy it was for me to choose it? See that? Because I've got the copper metal, so one of them must be a metal. So I look for a reaction that's got a metal. That's got no metal, no solid metal. That's got a metal, that's got a metal, but I've already ruled that out because we've got Cu 2 plus, because I know the 2 plus balances the 2 minus. So now I know this is my one reaction and that is my other. All happy? That's my 2 reactions. I found it. That's half the battle. So you know what I do? I rub out the ones that are not. Because I know. Anyone want me to explain how we found the half reaction again? Was there another zinc there, by the way? Or is there just one zinc? Just one zinc. So that was easy. But copper's got 3 forms. 2 of which have got metal. It can go to 1 iron or 2 ions. What if I'd used copper nitrate? If it was CuNO3, then it was a copper 1 plus. Nitrate NO3, 1 minus. But if it's a sulfate 2 negative, it must be a 2 positive. Okay. Can I, if you don't mind, I just want to work, I'm going to have to work down here a bit small. Now here's the next step. There's a better rule. You've got a rule on your data sheet that tells you how to work out the voltage, but I'm going to show you the old-fashioned method that you can use the proper method. But just look at this. You see that both that reaction and that reaction are written as if both gain electrons. But it always, if one gains, one must lose. So we've got to reverse one half reaction. So here's the rule. Look for the one with the biggest voltage. Which of those has got the biggest voltage overall? Is 0.75 bigger than 0.034? Which has got the bigger voltage? Irrespective of sign. Is 0.7? Would you want 0.75 in your bank account or 0.34? 0.75 rands or 0.34 rands? You obviously want 75 cents rather than 34 cents in your bank account. So that's the bigger one. Make the bigger one positive if it's not already positive. So how do I make it positive? I do this. I reverse it. And I write it in the reverse direction. So let's write it in the reverse direction. Here's the reverse direction. Zinc goes to form zinc 2 plus 2 electrons. And this becomes plus 0.76. You reverse the voltage as well. So what did I do? I look for the one with the biggest voltage. I make it positive if it's not positive. One of them has got to reverse. In this case, did this one reverse to make it positive? Yes. So now I know that it goes from zinc to zinc ions, and the copper goes from copper ions to copper metal. Those are my two reactions. I write them with arrows in those directions. There's no reversible arrows anymore. And now I add 7 plus 7, 6 plus 3, 4 volts, and I get, look, this is real messy, but I'm just going to put a line through that, and a line through that. What is plus 7, 6 plus 0.34? 4 plus 6 is 10. 7 plus 1 is 8, 9, 10, 11. 1, 10 volts is the battery that we've made using those zinc and copper. What did I read on my voltmeter? 1,05. Or whatever it was. But it was close to 1.1. Just that our solutions weren't the right temperature, the right concentration, everything. Do you see how easy this is, how nice this is? So which one is being oxidized? Zinc. Which one's being reduced? Copper. It's a redox reaction, and in that redox reaction, in the losing of electrons, this is the circuit. The electrons go through from the zinc is oxidized, through the voltmeter to the copper, then to complete the circuit we have a salt bridge. The ions move through the salt bridge to even out the... If you take out your salt bridge, it stops the current because it's no longer a closed circuit. And that you can prove by just getting this working, and then pull out your salt bridge, it doesn't work. The salt bridge allows the ions that build up in both solutions to migrate through the salt bridge. So at the zinc, what ions are building up or not? What's happening at the zinc electrode? Those ions are disappearing. So we need to get some more ions coming in through the salt bridge. At this one, the copper is producing, those ions are going towards copper solid. So those positive ions are disappearing, so the other positive ions must come through to replace their part, take their part. Something like that. The salt bridge keeps the ion concentration in the solutions even. And that's an electrolytic cell. So which one's going to be positive? Which one did we find was the positive one here? The zinc is losing electrons and forming that. I'm actually a little confused myself. I'm trying to figure this out from basic principles. Long years since I taught it. So if the zinc this shows it losing electrons. Where is it losing the electrons to? It's losing that to the voltmeter. If it loses the electrons to the voltmeter, it must be attached to the negative side of the voltmeter. Yeah. That makes sense. Because it's losing electrons at the negative. And so this must be the negative side of the voltmeter, this must be the positive, I think. What is the copper doing? It is gaining electrons. But if you check it out, I know that I'm correct in saying, okay, is the zinc being oxidized or reduced? It's being oxidized. If it's being oxidized, what electrode is this? Oxidation always occurs at the anode. So this must be the anode. What electrode is the anode in this case? It's the negative electrode. Do you see it's the opposite of this one here where the anode was the positive electrode? Why is the anode negative? Because the zinc has lost its electrons, therefore this is being made negative this side of your meter. And then at this side here, the copper is gaining electrons, so it is being reduced. And at this side, it is the cathode. And in this case, your cathode is positive. Look, opposite, opposite. How many beakers? 1 beaker, 2 beakers. What goes in? Chemicals. What comes out? Electricity. Anode in this case is negative, in that case it's positive. So it's opposite. What comes out? Electricity. What goes in? Chemicals. We started with chemicals, we ended with a voltage. We didn't start with a voltage like we did there and end with a chemical change. Lovely. You know what I think I'm going to get you to do? Would you, for the practice, would you mind trying what would happen if we used lead instead of, should we try lead instead of copper? So we get zinc and lead sulfate we'll use. Do the same, try and find it if we use lead and lead sulfate. PV. And just work it all out, which one's going to do which. Find the 2 half reactions, reverse the one with the biggest voltage and make sure it's positive. Everyone understand what I'm asking for? So let's make it lead and lead sulfate the solution. I think PV is PV2 plus, isn't it? Anyone found the half reaction?
Yes.
PV, is it PV2 plus?
Yes.
Okay, so lead sulfate, and the other one is still your zinc. Zinc and lead. Try and work out the voltage, try and work out which one's oxidized, which one's reduced. Remember, the one on top is the one that is oxidized. Guys, I've actually thought of a better rule.
What is lead again?
The one on top always reverses. How's that for a better rule? 1 half reaction's got to, the one closest to lithium always swaps around. That's a better rule. Got it, Joseph? No. Find the one on top, lead and zinc. Which one's on top?
What is?
Oh, zinc is on top.
Is lead PV?
Lead is PV.
What is PV?
PV.
Yeah, yes. So zinc is on top.
So is zinc still on top?